Welcome from my side at the Global Azure event. In this hour, I will give you information on monitoring and logging with .NET applications and integrating the logging feature from .NET with Microsoft Azure. My name is Christian. I'm working with Microsoft Azure before it had the name Microsoft Azure when it was Windows Azure. And I'm working with .NET since the early days. With the first beta version of .NET, I've started writing books. And now, just recently, a new book is available, a new edition of my Professional C# book. And nowadays, of course, writing .NET applications, it's important to use Microsoft Azure in many scenarios, and you will find many things here inside this book. The information I'm giving to you is information about diagnostics, different diagnostics namespaces with .NET, and using this with Azure Monitor. These are the main two topics of these 15 minutes. Diagnostics with .NET. Let's start with a sample application. Here, the first application I'm showing you is a very small application where I'm using new logging functionality. Let me switch over to Visual Studio. Here, you find a small diagnostic, just a small console application. And this console application injects the iLogger interface. With .NET, with the new .NET, we have the iLogger and iLogger interfaces, where we can log messages. Log messages, like here, log information. The iLogger interface, let me have a look here, peak definition. It's a generic one with a category name. So I'm using here the category name of the class runner. You can also use the logger factory to specify a completely customized category name. And this interface, base interface, peak definition, defines a begin scope method. Here, you can use this for creating a scope where multiple methods, multiple scopes can be within that for some hierarchical logging. Okay. An is enabled method to check if for the log level that's specified, if this log level is enabled. And the most important method here is the log method, passing a log level. So with the log level, we have different levels to write log messages, such as this is a critical, an error message, a warning message, information message, a trace message, or a debug message, an ID for the event, state information, exception information, and a formatter, a delegate for a formatter. So yeah, this is quite complex to use. That's why we have extension methods like this log information using logger.log information, use the level information, log error, it's the error level, log warning, and so on. One great addition with .NET 6 is using a source generator for logging, high performance logging. And here I have a log class, a partial log class. The name doesn't matter. What's important here are the logger message attributes. So with these attributes here, I'm specifying the event ID, the log level, the message, and a partial void method. So this partial void method gets an implementation from the source generator. I do not need to have a different NuGet package for this. This is implemented directly. The source generator is implemented directly with the logging package that we reference from the .NET 6 application anyway. So check the project file. It's a target framework for .NET 6, Microsoft .NET 6 SDK. I just have here for this application SQL Server, Entity Framework, and hosting for the dependency injection container, but nothing related for logging. This is all included. And if you create such a log message here, logger message event ID, some level warning, and a message example public static. This is an extension method here, a partial, so I'm not creating any implementation myself. Void my sample. Okay, and this for a logger gives me a count here. Now this method was created from the source generator. Go to definition. So this generated file here, logger message #, generated generates an implementation and uses a callback, a delegate for this. So this feature is mainly using two great features from C#. One feature is the source generator. Another feature here we use a delegate. This is an action. And now with .NET 6 and C# 10, the delegates can be cached. So there are not a lot of objects created. Everything can be cached here for this action delegate. So this is a high-performing logging implementation. And yeah, this method is used here. I can also pass any parameters and pay attention. Log information. Pay attention to the strings here. Game ID not retrieved from the cache. New game cache, currently games active, count games active. This is not an interpolated string. With logging, you do not use interpolated strings, but you also do not use here 0, 1, 2, and so on. Still, the parameters here that you define with this method, the parameters get into this message. And the reason you are not using an indexer here is with logging, this term that you use here is indexed. And you can have a fast query with all your log strings for the count, for the ID. Give me all the log information that contain an ID or account. So far for logging, where do we log the information to? This is specified from the create default builder method from the host class. Let me open an important website, source.net. With this method, you can also look inside the documentation, what's done there. But I think even easier, it's to pass this method name create default builder to the source.net website. This method is part of Microsoft Extensions hosting. Okay, here we have a great default builder, one without arguments, one with arguments. So let's step into this one. Okay, and here we have the implementation of this method. This website also makes it easy to find the original source code. Here we have a link for the web access, which references the GitHub repository of the source code. But inside the GitHub repository, it's so huge and it's often not so easy to find the correct source code there. It's a lot easier here. So with the create default builder, a host builder is created, configure defaults configures the host configuration, app configuration, configure services, and then we use a service provider factory. Okay, let's get into the add default services. With the default services, the logging extension method is called to configure logging. And here a first check is done. Are we running on the Windows operating system? Okay. If this is the case, if we're running on Windows, then a filter is added, a logging filter for the event log logger provider. This event log logger provider is logging into the Windows event log. And here we do not want to log verbose messages, but only warning and more. So this is the default setting here. Okay. Then the next thing that's done is the logging section is used. So you can configure logging in the app settings JSON file or any other configuration option you have with .NET, such as environmental variables, user secrets, command line arguments, or different providers. And you can override the setting here from this configuration, can override the setting for the Windows Event Logger. Next, if the operating system is not a browser, then we log to the console. Okay. So if it's not the browser, this is an important extension to this method for Blazor. If the application is running in a Blazor WebAssembly, we are not logging the .NET logs to the console. The next provider that's added after the console provider is the debug provider, which is using the debug class to write debug messages. With Visual Studio, find this information inside the output window. Add event source logger is the main logger you use. So here you can add a listener which listens to the pipe from the application specified by this event source logger to retrieve all the log information that you apply to. And next, if again we're running on Windows, then the Windows event log, add event log, Windows event log is added. Okay. And finally, you find a configuration for activity tracking. Activity tracking can be used for distributed tracing. We'll have a look on activities later on. Okay. Now let me step to the application. So here, I'm just using the default configuration for logging and configure logging, make some changes here, like I'm defining the minimum level to a trace level. I can also add other logging providers. Okay. What I'm done with this application is in a loop, just write some messages, an error message, use a delay, and also at the record here, I'm also using ND framework to create a record in the database. So starting the application with this in place, we should find an iteration, all the log information to the console. Sample one, starting game. From ND framework, we find the queries which are done, objects added, and extremely highlighted the error message. Game 4711 not found in the database, which is done here in the runner. Here with an error message, game ID not found, and this is making use of the source generator. Go to definition. Here is the implementation from the source generator, and here is my own code for somewhere an error message, game ID not found, log level error, and this is specific marked. You can add other providers here, like this JSON console provider. We have a simple console provider, a JSON console provider, and the JSON console provider, to show it nicer in the console, I'm defining the indent. Start. Okay, now we find all this log information in a JSON format. And here you also find the message game not found, game 4711 not found in the database, and the original format game ID not found in the database. And this is used for an index with logging. So let me go back to the slides. We have different sources. We have providers. Sources, for example, my own source, or systemnet, Microsoft Azure Framework Core, and providers where we log to. And all this can be configured. The predefined log providers are the event log for Windows console. There's also a simple and a JSON console, the debug log provider, and the event source log provider, which is a cross-platform log provider. You've also seen the new logging source generator with .NET 6 for high-performance logging using the source generator and cache delegates to increase the performance. Other than writing log files, we should also know about some counts. Like in Windows, we have the event log, and we have the performance monitor to monitor all different counts available. Previously, .NET Framework had such counts on Windows, but now with .NET, we have such counts independent on the platform where the application is running. And just recently, we received a new API. We have a traditional API, creating an event source class, deriving from the event source base class, and defining some counts to write. The new API is a lot simpler, but it's also more powerful. It's from the new system diagnostics matrix namespace. Let me get into an example here. The next step, and all the examples I'm showing, you find it in a open source GitHub repository for this event matrix. The same sample, a little bit extended. And with this sample, I'm using the meter type. Define a name for my meter. And with this meter type, I'm creating a counter, a foo counter. I'm counting the invocations of foos, an error counter, counting some errors. Okay. With the implementation here, error message, I'm invoking the add method of the errors here, of this counter. And calling the foo method, I'm adding 1. So how can you read the counts here, and what counts are available from .NET itself? You can install a .NET tool list. I've installed globally the .NET counters tool, .NET counters. Okay, with .NET counters, you have a list of all the counts available. List. So what you get here, and the information for the counts available is based on .NET Core 3.1. So we find information about the generation 0, 1, 2 collections of the memory of the managed heap, the time in the garbage collector, the size of the heaps, the large object heap size, some information on the thread pool, on ASP.NET Core hosting. If I'm using another option here, minus R5 for .NET 5, some counts have been added with .NET 5. So here you find system net HTTP, name resolution, sockets, and these are only the counts of ASP.NET and .NET. There are some more libraries like Entity Framework. Entity Framework offers counts as well. So let me start the application here, and this one is called the diagnostic sample meter. Start the application. Okay. While this application is running, .NET counters PS to find all the processes which I can check the metric information. .NET counters monitor -p this process. And if I, let me copy this first, counters, yeah. To monitor the information, I'm using monitor. You can collect the information, write the information to a file. Okay, and the .NET monitor, counters monitor, -h. I pass the process ID and also the counters I want to monitor. Okay. I think I copied it. Okay, process ID minus counters. And now let me monitor the diagnostic sample. Diagnostic sample, yes. But also system.runtime and Microsoft Entity Framework Core. Okay. And while this application is running, we have some argument out of range exception. This is an issue of this .NET counters tool, depending on the size of the screen I have here with this terminal. Okay. Now I see the generation 0, 1 counts, error counters go up here. I'm logging some error. I'm logging the foo method by second. Some tools can also use instead by second monitor this overall complete count. And here, how many save changes I've done in total. Save changes by 1 second, hit the rate from the cache and so on. Okay. So there's a new, quite powerful and easy to use API, and we have built-in counters for .NET, for the dependency injection container, for SystemNet, and many parts of the library. With System Diagnostics Matrix, we have the meter class to track different instruments, and now some different kind of instruments like a counter, a histogram, an observable counter, and an observable gauge. Observable gauge like non-additive values like the temperature from the room gives you some continuous value that you can monitor. And with the previous API, for example, you don't have histograms, and with histograms you can pass key value pairs and create some powerful graphical output from this if you use the correct tools for that. Another feature with logging is the distributed tracing. Now, creating microservices running on Azure, one service calls the other one. You want to see what happens here behind the scenes, what are the issues to track the correlating work. For this, we have the distributed tracing sample. Same sample, now extended using an activity source. So here I'm creating an activity source, and now remember the configuration from the dependency injection container, where some activity values are configured to log, to monitor a parent ID, to monitor a span ID. This is used with the activity sources. So here in the foo method, I'm creating a new activity source, starting an activity. Activity foo started. With the activity, you also have can optional pass some information. Is this a client? Is this a consumer? Is this a server? Is this just internal? A producer? Okay. You can also fire some events, explicitly mark some messages. We have an activity event in foo. Logging an activity, you can supply some package to it and a tag. All the tags and packages are shown looking at the activities. The package goes down all the hierarchy through all the inner activities, while the tags are only written within this activity. So here I'm creating an activity, and you always need to check for nullability, because the start activity method, if nobody is listening and nobody is interested to this activities with this name as specified with the activity source, then it always returns null. So you do not do anything, no events, no packages, no tags, do not log anything. So within here I'm using the new using to dispose the activity after the foo method ended, and I'm stopping the activity here. In between, I'm calling the bar method to create the bar activity here. Add another tag, and with this bar activity, also the package from the parent activity is logged. Now we just need some listener for this activity source for the diagnostic sample. And of course, we also have some activity sources in the .NET libraries. You can use the .NET Trace tool to check for the activities, monitor this. And you can also use Another great feature, Open Telemetry. Open Telemetry. Open Telemetry IO. This is a new way for logging, tracing, distributed tracing, matrix for all the different programming languages, all the different platforms, independent of a platform. What's great here with .NET, we have the functionality built in. So we can use the iLogger interface, use the matrix, use the activity class, which already exists for some time with .NET, and just map it to a standard output. Here we have some collectors that could be used to use this information. So we can use all this information in a platform independent way. Okay. Here I'm configuring the SDK from the Open Telemetry library. So here I'm using the Open Telemetry and an Open Telemetry exporter. I'm exporting the Open Telemetry information to the console, and this is specified. Is specified with this console exporter. I'm adding the source diagnostic sample. Okay, build and use this trace provider. So running the application here. Okay, should come up. Or maybe it already did. Okay, let's. Yeah, application is already running. So the application is running, and here you find all the activity information. There's a display name bar, activity kind, it's internal, start time. Here we have the activity tags, the bar tag, then full, then full activity, which has a parent of the bar activity. Here it's just written to the console, but of course you can use nice tools which gives you a nice hierarchical view for that. So another option for a different view with Azure Monitor. Okay. So here I'm using a connection to application insights. Manage user secrets. I have a connection string here. Instrumentation key for application insights. And yeah, some little bit issues currently. It's in preview. This package, the Azure Monitor Open Telemetry Exporter. It's a beta 3 version. And this beta 3 version has the issue you cannot use it at the moment with .NET 6 because it dependencies from the logging, from the .NET logging library. I guess this will be solved in the next 2 days when we have the beta 4. Okay. And here I'm configuring SDK create trace provider builder, create a resource builder with a different name for components in application insights, a service namespace and a service name, at the source diagnostic sample, like you've seen before with the console exporter. And I'm using the @Azure Monitor trace exporter now, retrieving the connection string from the settings of the application. So now we already moved into Microsoft Azure. But before that, let me go back to the slides. Distributed tracing. For distributed tracing, we have the activity source and the activity class. With the activity class, there's an ID associated, and this ID contains the hierarchical information, the hierarchical structure. So we have different parts of the ID separated by dot or by underscores for the different levels in the hierarchy. We have tags. So this is information logged with the activity. A package, information logged with the activity and also with all the children of the activity. And timestamp messages, which are the events. Tools you can use. I've shown you the .NET Counters tool. The .NET Trace tool can be used for performance analysis, creates a file with both metrics information as well as log information. And the most powerful tool, but this requires the most of the configuration, is the .NET Monitor tool. .NET Monitor information about processes, about dump traces, metrics, logs, operations. The open telemetry is the platform independent way of telemetry, of logging, metrics, distributed tracing for different libraries, and we have collectors that are independent. So creating microservices that communicate together, creating microservices implemented with different technologies. You can use the same collectors, the same logging facilities to find information across all your services implemented with different technologies. So with .NET, most important, the three different parts, logging, very flexible. We can add also now logging providers to write logs to application insights, to app services. We have metric information and distributed tracing. Azure Monitor. Azure Monitor is a collection of metrics, logs, and traces which you can use in different ways. Insights, different visualizations, analysis. You can act on this, for example, to scale up a service, an app service, or a container instance, to integrate information coming from Azure Monitor with also on-premises solutions. You can call into Azure Functions, logic apps, do mainly what you want to do. Let me show you another something bigger sample application I've done here. So let me open a project in GitHub Learn, the code breaker. The code breaker, I created an API, a bot application, and also a Blazor application. The API, let me start this. I had to find a different name than the original name, because with the GitHub repositories and everywhere, we remove the master main and changed it to the main branch. And I didn't want to change the game name to main mind. So instead I found a different name. So it's the code breaker here. Here I can send a post request to the service to start a new game, pass a string, a name, and start a new game. And then I can set moves to that. So here I have a game identifier received, and I can do some moves. Instead of sending a post request here and doing the move with the different code packs, I created a bot application. Let me get into the Azure portal. Okay. And here I have some container apps running. Oh, this is the wrong browser, the wrong portal. This one is the correct one. Okay. I have the code breaker API running, and also in this resource group, code breaker resource group, I have a code breaker bot running. So with this code breaker bot, there's this link here. First one, we should receive a 404. Yes, Swagger. I have a Swagger definition here. And with this start, I can run multiple games. So make a short delay between different games running. I'm defined now, let me run 30 games. And between the moves, there's a number of seconds to wait for the next move, and execute this. So one game is running with this ID, and let me execute another one and another one. So in summary, 90 games are running from 3 different runs. And yeah, we should see some action now. And let me switch to the Play Store Code Breaker app. You will find some reports of all the games that are running. Okay. And here, the bot user already saw the games that are completed now. So one time it took 6 moves to find the result. And let me go into the details here. Okay. The correct data defined by the API randomly, and it is not told to the bot. The correct data to win this game run is yellow, blue, white, blue. So you have 4 positions and 6 different colors, and the bot first selected black, green, green, white, and got a white result. Then the next move, a white result again. The next move, a black-white result until 6 moves. Then this matches this original setting here. Result found after 4 moves. Okay. And yeah, there's also a small bug into here. Look into this. So what I found out here, if I missed something, if nothing was found, no black and white, the bot could reduce the possible options by a lot, but in this case, it doesn't reduce the options a lot. That's why it takes so many moves here, but the human should also be given some possibility to win against the bot. Okay. Now let me open information from Azure. Okay. With this resource group, we have the a log analytics workspace configured, code breaker logs. Okay. And here, don't want to sign out, no? Okay. Let me go back into. Yeah. Send. Tom. Yeah. Received. Approve. Okay. Code breaker. From here, let me open the log analytics workspace. Here I now configure to send a lot of the logs over. So with the logs here, the log analytics workspace, from the container apps, by default, I see the console output. Inside the container app console logs. Run. And now see all the different log options. So a game ID, this is state information, a color for the packs, some, yeah, we see the time it took with some of the logs. We see also the different color packs, and from anti-framework core, we see the we are accessing the Cosmos database here. We see the queries generated. There's quite a lot of information there. We use the Custo query language, KQL query language to go through the logs. For example, to only check this table from the log information where the container app name equals code breaker bot, or the container app name equals code breaker API. Okay, then let me run this from the last 24 hours. So I see the information for these logs. State message query from database. We can also create a chart from this, the Custo query language. Let me do some summary here. Summarize event count, create a count by bin time generated. Is a different column here for 1 hour, and render a time chart. Okay, for every hour. Now we created a lot of logs recently. Can render a time chart or a bar chart. Okay. Logs received from here, directly from logging. Let me also open the connected application insights, Codebreaker Insights. Okay. Codebreaker Insights, we find an application map. Application map, who is communicating with who, and also easily find information. Hey, there's some issues. Yeah, everything was running fine, but going back in time, I had some issues, find something red, and I can dig into that. How does this relate to what? Give me investigate performance here. What's slow? Why is it slow? And it gives me detailed information based on all the distributed tracing, logs, and metrics information. So going back to the slides, with logs, visual dashboards, we can create alerts to create an Azure resource which needs to be resolved, and you can automatically start the logic app, create some automatic reaction, and also inform someone about this alert. And we have the cool application insights for live monitoring, getting live log data, performance monitoring, and also see what the users are doing in what order. So as a takeaway with .NET, we have great features for logging, metrics, distributed tracing. Now with .NET 6, a source generator, the new system diagnostics matrix API, open telemetry, and a great features collecting this information within Azure. If you have any questions, I'm here the next hour in the session. We can talk about all the different features in Azure and .NET. You will find all the samples. You find it already in github.com /CNI Global Azure Austria. And also check my blog. Thank you for coming.